starboard side, you're gonna go fucking nuts.
Penn, move to your starboard. Cornell to your port.
Let's go, Cornell. Just like that's a good idea. Let's go. Come on, get it now. Let's go. Here we go now. Look at it. Look. Accelerating with the finish.
Cornell Junior Varsity.
Okay, here they come, Andy. Now.
Go, Rick! Come on, Rick! Go, Rick!
Cornell Life Race.
Congratulations. Good.
Where the fuck are they? That was the Penn. Oh, I see. I had it on telephoto. That should have been doing that.
Ergometer, the project that I've been working on for Professor Ruina. My name is Jeremy Rawlinson, and I'm a senior mechanical engineer here at Cornell University. I'd like to explain some of the components of the machine and focus in on the parts. When an oarsman rows on the ergometer, they pull on the handle which is connected to the handle chain. Here it is wrapped around the upper fixed pulley that we've made and is diverted down to the floating pulley. The chain then continues up to the ergometer flywheel. From there, it traverses the lower fixed pulley with attention to be taken up by the system that's underneath the monorail. This is basically the Concept 2 skewer assembly, which usually fits inside the monorail. From the floating pulley, there's a bicycle chain which is wrapped around a gear. That gear is fixed to the axle, as well as the wheels, so when a rower pulls, the floating pulley is moved upwards, creating a torque about the gear and the wheels, causing the erg to move backwards.
You pull on this chain and it pulls this flywheel here. What distinguishes this machine is that the chain on its way to the flywheel passes by this little in-between pulley here. So whatever tension there is in the chain which pulls the flywheel, twice that tension pulls on this chain, where this chain is wrapped around a sprocket, which is connected to this axle to these wheels. There's a thrust on the floor, which is proportional to the tension here. In particular, it's a thrust on the floor, which is 2 times this tension multiplied by the ratio of the radius of this sprocket to the radius of this wheel. And all of that has been figured out, so that whole ratio is about 1/3, which is about the same as the lever arm when you're in a rowboat. So there's a thrust on this machine about equal to the thrust on a rowboat, the net thrust from the oars. On the other hand, there's a drag on the boat, which this machine doesn't have in its current incarnation.
We're hoping to rig up the machine so that we can row hard and have some return mechanism on the recovery.
You want to keep the tension that's about constant. A different constant depending on how long. Or actually, what you might try, just to start with, just hold it still. Just don't move. Yeah, that works.
No, I can't see where.
Have you tried it, Jeremy? Oh my gosh. That's good.
Bad design. This was what we thought was going to happen at some point. Oh, no.
So what do you